Welcome everyone to the talk on studying computer science at the University of York. My name's Nick Pears. I'm a senior lecturer and the admissions tutor in the Department of Computer Science. I teach the first year theory module in the first year covering discrete mathematics, and I supervise third year undergraduate research projects in computer vision and robotics, which is also my area of research. The image on this first slide shows our department building, which is on the new Heslington East campus and is about 10 years old. I've split this talk into two parts. The first part presents some good reasons to choose to study computer science at York. The second part presents the programs that we offer and gives an overview of their content. The second part also has an image of our departmental building as a visual marker, so it's easy to scroll forward and access this information more directly. For example, you may wish to revisit program content later. We recognise that lots of universities offer good computer science programs across the UK and beyond, so why choose York? Here's a few good reasons. First, we offer a broad program content that allows our students to access a deeper understanding of the subject as a whole. In particular, we cover the hardware of computational systems in much more detail than many of our competitors, which gives more insight into the implementation of computational processors. The way we deliver the learning experience has been given the highest award, a Gold Award, by independent higher education assessors within the Teaching Excellence Framework. Secondly, all of our programs are available with an industrial placements year, which results in very high student employability statistics. Thirdly, we're a high-ranking research-active department across many different fields of research. This has a significant positive impact on your learning experience. Other great features at York include modern, bespoke teaching facilities and modern modes of learning, such as the flipped classroom. We have a low student-to-staff ratio, 12:1, and the city is very attractive and well connected with a great cafe culture. York is a great place to live for 3 or 4 years, and you might even choose to base yourself here after your degree. Indeed, York was designated the best city to live in by The Times in 2018. Here's a view of York Minster with a large cafe in the right foreground. Let's visit our broad program content. Software is well covered in all of the top computer science departments, but here the hardware of systems and devices is also well covered. So our students have a deep understanding of all the layers of complex computer-based systems and can handle the high complexity via abstraction, which is the hiding away of the detail that is unnecessary for what you are currently trying to understand. This makes for better computer scientists and engineers. All of the devices shown in this image, such as robots, 3D cameras and 3D printers, and augmented reality eyewear, are either available within our department or accessible within the university, such as in the nearby robotics lab. Let's move on to your job prospects after your computer science degree at York. Here we present the latest UK computer science graduate salary data available from the Institute of Fiscal Studies. The figures on the right show salaries 5 years after graduation. That's relative to the UK computer science average, which is about £25,000. So York graduates earn around £40,000 on average after 5 years, which ranks 6th overall in the UK. Our industrial placement program is one of the key benefits of coming to York and is available on all of our programs. On this scheme, you work for a company for a year after your second year and get paid and gain real experience. We employ a full-time industrial placements coordinator, Luke Bryant, shown on the right, to take all of the administrative hassle away from our students. Here's just a selection of our most recent placement companies. Placements are available across a very diverse set of industries and organisations. For example, software engineering companies, financial companies, computer systems providers, games companies, defence and the National Health Service. So there's something for everyone. So why do a placement? Firstly, doing a placement is a low-risk way of trialling a career path and seeing if it's right for you. Many students return to their placement employers after their degree, and many others move on to something different. Secondly, our statistics show a significant and consistent increase in our students' employability when they have been on an industrial placement. Over the last 3 years, 99% of our placement students were in professional level employment or further study 6 months after graduation. This compares to 86% for those who didn't take a placement. Thirdly, placement students command higher salaries, with the average annual gain being around £4,500. Finally, when students return from placement, they outperform those that don't go on a placement. We're not sure why. A well-established work routine, maturity, and a deeper understanding of professional context could all be factors. Let's look at the financial aspects of placement. First, the placement fee to the university is 20% of the full tuition fee for that year, and student finance is applicable to that. You're paid on your placement, it's a real job, and recent placement salaries have ranged from £16,000 to £45,000. Outside London, the £17,000 to £20,000 range is where most placements fall, whereas inside London, £20,000 to £30,000 is typical. Moving on from placements, let's now look at our facilities and teaching methods. The last decade has seen a large campus expansion called Heslington East, costing more than £750 million. The computer science building shown here is on this new campus and was opened by IBM's Chief Technical Officer in 2011. The building has custom-built labs and spaces for both teaching and research, and 24/7 card access for all our students. We have modern teaching and learning methods, and delivery of our programs is moving to the flipped classroom model. This means that rather than lectures being the centerpiece of the learning experience, sessions where students actively engage in problem solving, coding, and other practical classes are the focus. All of the resources such as online lectures, web resources, and reading lists support these productive activities. So the main focus is to develop and sharpen the skills and abilities of computer scientists and engineers, and to foster clear concepts around computational thinking. That is, how to think like a highly capable professional computer scientist. An important point to note is that we already have 3 successful online-only MSc courses, which puts us ahead of our competitors when developing learning experiences where many resources and assessments are delivered online. This has particular relevance in the current COVID-19 situation. In terms of academic supervision, our department has a low student-to-staff ratio, 12:1, which enables small group teaching. We are currently planning to have a mixture of online and face-to-face teaching sessions, with the exact details depending on COVID-19 safety guidelines and associated risk assessment. On arrival, all of our students will be allocated a personal supervisor who can be called on for help and advice, both for academic matters and pastoral affairs, such as how to access the various support services within the university. In terms of research activity, we are a high-ranking research-active department across many different fields of research, such as computer vision, AI, cybersecurity, real-time systems, and human-computer interaction, to name just a few. This is important. It means that you will be taught by world-leading researchers, and our research shapes the modules taught to undergraduates in the 3rd and 4th years of your chosen program, including your individual research project in your 3rd year of study. On the right of the slide, you can note that we are a top 10 UK research department according to the most recent REF Research Quality Assessment exercise, being equal 7th with the University of Oxford. Our research activity directly impacts on the learning experience of our students. Also on this slide, we show you 3 of our research labs. Top left is the Computer Vision Lab, with a light stage of cameras and lights for capturing 3D images. Top right is our Robotics Lab, where we have both legged robots and flying drones. These are both recent 3rd-year undergraduate research projects. Finally, in the bottom centre, we have our Human-Computer Interaction Lab, which is focusing on the development of assistive digital technology in the home environment. It is well known that there has been a long-standing gender imbalance across all computer science departments in the UK and beyond, with the intake of women often being lower than 5%. Our most recent intake has shown that we are close to achieving a 1 in 5 intake of women, and we hope to improve on that. To address gender inclusiveness, Professor Helen Petrie is our Athena Swan Lead and Gender Equality Champion. Athena Swan is a programme that is committed to advancing gender equality in academia, in particular addressing the loss of women across the career pipeline and the absence of women from senior academic, professional and support roles. Currently we have 6 women on our academic staff, 4 of whom are professors. There are several different international opportunities available for our students. In the Study Abroad year, you can swap out your second year of academic study at York with that of another university. Students who study abroad for a year currently pay a significantly reduced tuition fee to York and no tuition fees to the host university. Our summer schools, travel awards, and international study centres allow students to get a taste of living and working abroad without committing to a full year. Finally, our Languages for All courses cover around 14 languages and are free for first years and subsidised for other students. There are lots of societies that you could join when you come to York. Some of these allow you to get involved with computer science in a wider sense or just socialise with other computer scientists. Examples include HackSoc, CyberSoc and FragSoc, which is our PC gaming society. In the second part of this talk, I'll describe the programs that we offer and give an overview of the different streams of topics that you'll study. This is an important slide because it shows what programs you can apply for. We offer 3 groups of programs. Firstly, our computer science programs are our core offering. The vanilla flavour is another way of putting it. This is available at bachelor's level, which is 3 years of academic study, or master's level, which is 4 years of academic study. Secondly, we offer a pair of specialist programs that are only available at master's level. These specialisms include artificial intelligence and cybersecurity, perhaps the 2 highest profile areas of computer science in recent history. Finally, we offer a joint program with mathematics. So roughly half of your degree is taken in each department, and this can be at either bachelor's level or master's level. All of our programs are available with or without an industrial placement, and adding up all the different options means that we have 12 degree programs in total, with 12 different UCAS codes. All programs except the joint maths programs have the same content in the first 2 years, and so it is easy to switch programs, although we do check that you are doing well academically if you want to switch up from a bachelor's program to a master's program. It's much harder to switch between our joint maths programs and our straight computer science programs, so that's the most important decision to get right upon entry to the university. We have developed a new curriculum which started in the 2019-2020 academic year, so it will be nicely bedded in by the time that you arrive. We've done this because computer science is a continually changing academic field, and the required skill set of professional computer scientists in industry is ever changing. For example, a decade ago, there was no requirement for skills in deep learning. Now they are in high demand, and consequently graduates with such skills can command high salaries. Finally, the University of York is continually developing its pedagogy, and we have embraced the latest teaching and learning ideas in our new curriculum. This rather complicated slide is important and shows how our 8 topic streams are built into our program structure. This structure applies to all programs except the joint programs with maths, which have a trimmed down version that we'll look at a little later. The 4 stages denoted by the black blocks along the top are just the 4 different years of academic study. 3 stages for a bachelor's degree and 4 stages for a master's degree. The optional industrial placement year slots in between stages 2 and 3 and is not shown here. The bright green colour that is mainly on the left of the chart shows compulsory modules, while the dark grey shows optional modules. What this shows is that most compulsory content is in the first 2 years and most optional content is in the 3rd and the 4th years. This is the pattern that you should see in all good computer science programs. The idea is to provide good foundational knowledge. You learn the ideas and become equipped with the technical skills that all good professional computer scientists should know and have. At the end of the 2nd year, you have studied enough different topics to know what you really like. This puts you in a much more informed position to select your optional modules and individual research projects. Obviously, if you are on one of our specialist programs in AI or cybersecurity, then this will shape your option choices. These optional modules are closely related to the research going on in the department. And since we are a highly rated research department, this lets you get closer to the state of the art, particularly as you progress from stage 3 to stage 4. So let's go through these 8 themes. They are mostly self-explanatory, but I'd like to add some substance to each of them. In the theory theme, we start with discrete mathematics in the first term, and then go on to study formal languages, computability and complexity. Later options include formal methods of software assurance and quantum computation. Don't worry if you don't understand all of these terms. I'm just trying to convey the broad ideas here. Our second theme is software. First, we teach you procedural programming using Python, and then object orientation using Java. There are lots of practical exercises to help you learn from the ground up. Later, we progress to data structures and algorithms, paradigms of programming, and software testing. The Systems and Devices theme is wide-ranging in that it covers the hierarchical, layered approach to implementing complex computer systems. It includes computer architectures, operating systems, networking, parallel and distributed systems, real-time computing, assembly languages, and compilers. A data theme has been introduced as we now live in a world of high-volume, richly descriptive data. So we need to know how to describe this statistically and how to visualize large volume data. There is a crossover here with the intelligent systems strand in that we need to employ machine learning for data mining. There are also the more routine but highly useful topics such as understanding and using database management systems and query languages. Our fifth theme is human-computer interaction, or HCI for short. Computer science becomes a design subject here, with the end user's experience being of paramount importance. A certain computer manufacturer is famous for building smartphones and laptops that are very easy to use, for example, and that's the sort of end result we're aiming for. In addition to user-centered systems design, this theme also covers quantitative and qualitative evaluation methods for HCI. The intelligent system theme covers a range of AI topics. This includes problem representation and search strategies, general machine learning and optimization methods, deep learning using neural networks, computer vision, games AI, and biologically inspired agents and algorithms. The engineering theme presents you with a team software engineering project in your second year. Issues covered include software life cycles, management of projects, and stakeholder evaluation. The theme also has an individual research project of your choosing in your third year and a further, more sophisticated team systems project in your fourth year if you are on a master's program. Additional optional modules are available in adaptive and autonomous systems and in high-integrity systems engineering, where specialist techniques such as formal methods for software correctness are employed. Our eighth and final theme is cybersecurity. Cybersecurity concepts are integrated into the other 7 streams, and it is a stream in its own right from the third year onwards. It does come in a little later than the other streams, as you do need good computer science foundations to build upon to understand this. The theme covers network security, cryptography, malware, and the forensic analysis of cyber incidents. If you're interested in one of our joint computer science and maths programs, I'll now show you what computer science subject you don't study in order to free up roughly half of your study time for mathematics. The key differences are as follows. Firstly, you don't study Stream 5, the HCI stream, at all. In the second year, you can choose between the study of systems and devices and intelligent systems. More specifically, you can choose between Intelligent Systems Part 2 and dipping down for Systems and Devices Part 1. This is a first-year Systems and Devices module that would actually be taken in your second year. Your third year includes 50 credits for the individual research project in the engineering stream, which is just under half of your study time. The remaining 70 credits are selectable from computer science and mathematics, weighting these according to your preferences, but also bearing in mind any advertised timetable restrictions. Here's our A-level offer levels for our programs. If you're not taking A-levels, we do our best to match to an equivalent level in your set of qualifications. Note that all of our programs require an A grade in mathematics. All of our bachelor's programs require 3 grade A's overall. All of our master's programs require an A star and 2 grade A's overall, with the exception of the Joint Mathematics M-Math master's program, which has a 3 grade A's requirement. We don't interview applicants, but we do offer post-offer visit days where you can learn about our programs in more detail, experience life as a student in the department, and discuss your application with an academic. We also make contextual offers that aim to assess potential and recognise achievements in the context of potentially challenging home and school life. There is a possibility of grade reductions in offers for students who meet certain criteria. Please search for York Contextual Offers for more information. Thank you for listening. If you have any questions, please use our online open day chat room. Alternatively, please email our admissions team at the address shown on the slide. I hope this talk helps you decide where to apply, and I hope to see you in York on one of our excellent programs.